right, welcome to Business Calculus. So we are going to start off, if you notice the first three sections I put as optional. I would encourage you to do them, but they don't count towards your grade. And it's just a slight algebra review, remembering what functions look like and how to operate them, that type of stuff. So we're just going to dive in to section 2.4. So we're going to talk about limits and what a limit is. So first of all, if I tell you that, and I'm making stuff up, if I say that f of x equals 2x plus 6, we should recognize that this is a linear function. So it's linear because if I graph it, it makes a line. Okay? How do I know that? Because this is essentially y equals 2x plus 6. Since it's a y to the first equals an x to the first, that tells me it's linear. All right, so this is my linear function. Everything that we do for now is going to be functions. If I ask you what is f of 4, then you would know to evaluate this function at 4. In other words, if I shove in an x value of 4, what y coordinate pops out? So 2 times 4 plus 6 is going to be 8 plus 6, which is 14. So what do we know? We just figured out that the point 4, comma 14 is on this graph. So if I graph it very sloppily, I find out that my y-intercept is 6. My slope is 2. So this is not drawn to scale, okay? And I know if I shove in a point or an x value of 4, that its corresponding y-coordinate is 14. That's what I know. All right, limits let us explore the graph in a more detailed manner. So what limits allow us to do is say, as I creep closer to my target x value, so in this case, I'm just going to say it's 4, what y value do I creep close to? So here's how we write it. You're going to get sick of me saying this. Math people are very, very lazy. Okay? Everything that we do is a shortcut for something else. So instead of writing the word limit, I'm going to write L-I-M because it's too hard to write the I and the T. Okay? Underneath it in a subscript, which means a tiny, tiny little font, I'm going to say I want x to get infinitely close to 4. Okay? I want x to get infinitely close to 4. And what do I want to take the limit of? I'm going to take the limit of 2x plus 6 as x gets close to 4. Okay? So we've got a few strategies here. All this is asking me is what y value am I creeping close to? Okay? Am I creeping up to? That's the question. Up to. So in other words, if this is my x value of 4, okay? That's my x value of 4. As I creep up to an x value of 4 along my function, okay, what y value am I creeping up to from this side? Well, I'm creeping up to a y value of 14. As I creep up to an x value of 4 from the right, what y value am I creeping close to? Well, I'm creeping close to 14. So as I come at it from the left, I creep close to 14. As I come at it from the right, I creep close to 14. Does 14 equal 14? Yes, it does. So my limit is 14. And at this point, you're thinking, why on God's green earth are you doing this to me? Because it doesn't stay as easy as a line. Okay, and that's what you got to remember. Calculus is a whole lot more difficult than just, hey, look, it's a line. Okay, so we're going to have some strategies as we go through the back half of chapter 2. So strategy number 1. Part of my job is to teach you how to be lazy. Okay, strategy number 1 is, can you use direct substitution? Okay, if you can use direct substitution in your function, then there's no reason to not. Okay? In other words, I look at this. Is there anything keeping me from evaluating this at 4? Is there a variable in my denominator that's going to make it go undefined? is there a square root that's going to make it go into imaginary numbers? I mean, just anything like that. Is there anything weird going on? If there's nothing weird going on, then use direct substitution, okay? Number 2 is if I can't use direct substitution, can I use algebra somehow to make this thing work? And one of the methods is going to be factor and reduce. So can I factor and then reduce it to see how to go from there? And then another method might be rationalizing the numerator. And I don't expect you to know what this stuff is right off the top of your head. I'm just giving you a little list. So rationalizing the numerator. Okay. If neither of those works, then what I can do is go to 2 other options which are tedious. I don't like using them, but I can if I have to. I can make a table of values. Okay. Or if I need to, I can draw the graph and look at it from there. Okay. I can draw the graph and look at it from there. So what I did up here was I used direct substitution, because if I evaluate at a 4, 2 times 4 is 8, plus 6 is 14. So I got an answer. The limit as x approaches 4 of 2x plus 6 is 14. So direct substitution works. But what else did I do for you? I also drew you a picture. As I creep at it from an x value of 4 from the left and from the right, did I get the same y coordinate on each side? Yes, I did. So I drew a picture on that one. So I drew the graph. Okay. And then these other ones we'll get into pretty dang quick, because that's where we're headed right now. But that's essentially what limits are, is I want to see what's happening on either side of my target point, or either side of my given or chosen x value. So and it may be infinitely close, it may be a little bit further away, but that's what I'm trying to do. That's your goal, is to find out how to do this thing. Okay, so the next video, I'm going to do some examples.